introduction. Most of us in the plant breeding and seed world are familiar with Carol Deppe's fame and have probably read at least one of her books, which I believe you brought with you.
Yeah, the books are up here on the table if anybody wants to look. And they're undoubtedly at the Grassroots bookstore, the bookstore associated with the conference. And of course, they're available on Amazon and so on.
Are you on?
Yeah. Okay, there we go.
So these should be available there's going to be a bookstore when we have a conference for the next 2 days. Breed your own vegetables. If you have not read it or don't own it, you should. This is a foundational,
Bless your heart.
inspirational book by Carol. So some great literature, fantastic experience and knowledge here with us today. Carol's going to share some music with us, some of her experience, some of her knowledge. We're going to go old school with some whiteboard drawings. And we're going to try and leave plenty of time for question and answer. Do you want interaction along the way, or do you want to wait?
Let's have people hold questions till the end, but I will make sure there's plenty of time for questions at the end.
Everybody hear Carol in the back?
Yeah.
Great. All right. Well,
Okay.
with no further ado, Carol Deppe.
Thank you. Hello, everyone. I didn't tell them I was going to bring a guitar and play some songs, because that way they wouldn't have any chance to say no. I'm going to start us off with 3 songs, and there's a reason for these 3 songs. The first one is a song that goes to the tune of the Stars and Stripes Forever, and it's "We Don't Want to Eat GMO." And I thought that would be a good way to start us, because the fact is, the thing that we all have in common, whatever our role in the organic community, the thing that all of us have in common is the fact that we are committed to organics, that we think that this is a more sane version of agriculture than most of what there is out there, and we're working to do our part to make that a stronger and more vibrant sector of the seed community. We want more organic seed, we want more organic plant breeding, and we want more organic food out there.
Yes.
So I thought I'd start off with my little song, my version of Stars and Stripes Forever. We don't want to eat GMO. We really don't care how they tout it. It's all under corporate control. And as for its safety, we doubt it. We can't live on just food alone, but we also can't live real long without it. Control of our seed means control of our food, so let's take back both seeds and food and shout about it. Rachel Hultengren, who's responsible for the Open Source Seed Initiative sponsored podcasts, is here. Rachel, stand up. She's going to be recording a number of the events that where Open Source Seed Initiative is involved. Open Source Seed Initiative is having its own meeting on Sunday morning, 9 to 12, at the Alumni Ballroom C. Right, okay. So if you have a chance, drop by, and there's a free shindig and a free breakfast, and you can visit with other people who are involved in the open source seed movement or who want to know more about it. And it's a chance for people who are growing seed, for example, to find people who buy seed, especially of Ozzy pledge varieties and so forth. our idea of an agenda is about a 5-minute introductory talk at the beginning, and then we just visit with each other. Because we figure everybody's kind of burned out on regular talks at that point. So come if you have a chance. I will be talking about plant breeding, but it will be very definitely plant breeding dedicated to expanding the organic sector of the market, of breeding varieties that are particularly good for growing in organic conditions. The critical thing, though, that actually comes along with plant breeding is seed saving. You can't do any plant breeding at all unless you know how to save seeds. On the other hand, you can't save seeds very well unless you actually know how to plant breed too. So I thought I would do a song that has to do with seed saving. And this one is based on the tune Scotland the Brave. And I call it Seed Savers Brave. Because basically, most of the commercial seed sector, the big multinational corporations, are working very hard to get farmers worldwide, farmers and gardeners, to quit saving seed and just buy it every year. We need to do everything possible to resist that trend. That means growing open-pollinated varieties when good open-pollinated varieties are available. That means doing trials of our own in order to find good open-pollinated varieties that are as good as any of the hybrids, and a lot of them are. In addition, when people sell things like pelleted seed, realize that that's another thing that locks you into having to buy seed from them every year. The minute you adapt your operation to pelleted seed, you at that point are subordinate to big commercial seed companies that can produce pelleted seed from then on. So anyway, this Seed Savers Brave, of course, has got open source seed initiative in it. And, you know, if you invite me to give a talk, you're stuck with hearing a lot about open source seed initiative. I don't apologize for that. We are the bold seed savers, we are the planet changers. Join in our noble labors, grow Ozzy seed. Let Ozzy be a fertile haven, tolerate no corporation that with chains of patents craven threatens our seed. Let Ozzy be a fertile haven, tolerate no corporation that with laws and litigation threatens our seed. Let Ozzy spread to every nation, every farm and every station. Let the Ozzy pledge so sacred protect our seed. We are the bold seed savers, we are the planet changers. Join in our noble labors, grow Ozzy seed. Let Ozzy spread to every nation, every farm and every station. Let the Ozzy pledge so sacred protect our seed. So, when you do your seed saving, when you learn seed saving, when you apply plant breeding in order to do better seed saving, when you're doing plant breeding, seed saving is essential for it. Think of it in those terms. There's a whole huge multi-mega-national corporate movement trying to strip you of the knowledge and the practice of saving seed. And it's our job to resist and reverse that. The third song I'm going to do it has to do with growing beans, because I'm going to be talking about growing beans, And I think everybody should grow beans. Everybody should grow dry beans and every other kind of bean that there is. It's such fun. It's so easy. A number of my plant breeding projects are beans. I didn't plan it that way. A lot of times beans will just kind of breed themselves, and all you have to do is sort of notice what they're thinking of doing and just help them along a little bit. A lot of plant breeding projects are a lot of work. A lot of bean breeding projects are really pretty easy. I thought I'd talk about, how many people here are either Pacific Northwest or California? A dry summer place. Okay, this is absolutely marvelous place to grow dry beans. I think all of you that raised your hand should be growing dry beans. Usually, when we're thinking in terms of staple crops, very often we're talking about corn, and I grow corn too, and flour corns. However, the beans are actually a whole lot easier in a lot of ways. Corn is really not all that well adapted to places that have got very little summer heat and have got frigid nights. There are plenty of heirloom bean varieties that actually think that that's just a really fine way to grow. A major trick in doing well at growing dry beans in our area is realizing that what you want to do is plant your beans somewhere where you can cut the irrigation off. So in other words, don't mix it into an irrigated garden where you're going to have to irrigate the garden all the way through August. Instead, what you want to do is cut the irrigation off, usually about the beginning of August. That way, just as the beans start drying down, some of the pods start drying down, because once pods have dried down, once they get rained on, then they're subject to molding. So we can produce a quality of bean seed that is outstanding compared to what can be done in most of the rest of the world, because mostly it just doesn't rain in the summer, and we either dry farm our beans, or if we irrigate them, we can irrigate them up to about August 1st, then cut the water off on them. There's some details in this song. This song it's based upon the song Deep River Blues, and it's a bean growing blues, of course. And it's got some details in it I'm going to come back to. Let's see if I can do this here. This is sort of a stretch for me. There we go. Let it rain, let it pour, 'cause we're already in the door. We got them bean growing blues. Let that rain come driving down, 'cause our bean seeds all in the ground. We got them bean growing blues. First we till, then we sow, weed and water, watch 'em grow. We got them bean growing blues. 4 inches high, and it's time to thin, unless the cucumber beetles get 'em. In which case we gotta plant them all over again. We got them bean growing blues. August 1st, we stop irrigating. Our plants are drying down. We're just waiting. We got them bean growing blues. Cut our plants, get them in crop will be down the drain. We got them bean growing blues. Let it rain, we don't give a darn. Our bean plants are all in the barn. We got them bean growing blues. I started to say Rachel was going to be recording a session of folks associated with Ozzy and give us a few weeks, and the songs will probably be up on the website, the Ozzy fight songs, which include 2 of those and 3 others. Okay, so why do we plant breed? There's 2 major goals involved in breeding plants, or 2 major purposes that you might have for breeding plants. One is that you want to take some material, a variety, and you want to change it, develop something new out of it. The other is that you want to take a variety and not change it. You don't want something new, you like the variety the way it is. In order to develop something new, you need to do plant breeding. And in order to avoid accidentally producing something new and ruining your established variety, you need to do plant breeding. So, when it comes to breeding for organics, there are a bunch of approaches, and a lot of times people think in terms of, oh, we need resistance for this specific disease and that specific disease. And sometimes, in fact, that's true. But a lot of times, we can take a much more generalized approach. If we breed for extreme fast growth and vigor on organic soil, basically the plant can just outrun all the problems. So you can actually not have to breed for specific resistances in a lot of cases. There's still some specific things you might need. So that's one approach, is to just have plants that are so well adapted to growing in an organic system and are so well adapted to your region that they just jump out of the ground, and you can plant whatever hybrids you want next to them, and the hybrids will look like wimps. Now you see, I'm saying something different from what you usually hear here, because people are usually trying to say, oh, you know, we want to be able to breed stuff that's organic adapted that does as well as the hybrids. And I said, bullshit, we can beat the hell out of the hybrids. That's a low bar. We can do a whole lot better than that. But it requires us taking our organic plant breeding to a different level. Now, I think one of the things that requires is different and more powerful selections specifically for organic systems. And I think another thing that it requires is paying appropriate attention to the issue of genetic heterogeneity in plants. The problem as it stands now is that varieties that are sold commercially are generally very inbred, and this is particularly a problem with varieties such as squash, for example, where in order to develop something that's uniform enough to meet the standards for being able to put intellectual property on them, like plant variety protection, the plants have got to be uniform. The leaf form has got to be uniform. Everything's got to be uniform. All that uniformity is not necessary if what you care about is the fruit. In order to market the fruit, you probably are going to need uniformity for the fruit and for flavor. and you'll need uniformity for some agronomical characteristics in order to be able to grow it easily. But you don't necessarily need and are harmed, in fact, by breeding for uniformity for every possible trait. So I'm going to talk a little bit about some of my own plant breeding projects and illustrate these ideas in the course of these projects. I'm going to start with beans, and that's why I wanted to get you all fired up about beans. I've ended up getting fiercely committed to cowpea breeding. Now, this is not something that I actually spent my childhood and my young adult life thinking, oh, I want more than anything else to breed cowpeas. In the Maritime Warren Northwest, where nobody even knows how to use cowpeas. And where basically nobody grows cowpeas. No, that's not how it happened. I was looking for, I was just trying a whole lot of beans, different species. I mean, obviously, one of the ways that you can diversify with respect to your legume crops and diversify with respect to your overall farming patterns is to grow legumes throughout the year. So you're growing different legumes in different niches. Some of them you're overwintering, like you can overwinter your fava beans, for example. And then you've got the Phaseolus vulgaris, the common beans that you can grow in the summer. And well, the beans, even the beans that supposedly are relatively inbreeding, have a tendency to cross, especially if you have got an organic garden or farm, especially a long-term organic garden and farm. Most of the isolation distances are from university fields that are relatively sterile and have very low insect diversity and insect pressure. So they can, when I first started working with beans here, back when Jim Baggett was the plant breeder, his standard isolation was 3 feet apart. You know, just enough, 6 feet apart, something like that, just enough to keep from physically mixing the beans together. Well, I pretty rapidly found that just about everything crossed at that distance. In fact, I could get crosses of beans to start breeding projects with by just interplanting them. I almost always get crosses. So I got involved in cowpea breeding because I thought it would just be nice to have another species. I had spent a piece of my childhood in Georgia, and so I was familiar with eating cowpeas. I thought, well, that would be nice. Let's just look for all the earliest cowpea varieties that you can find and try them all and see if any of them will live here. Well, the very earliest variety of the ones that I tried was called a lady pea, and it's a little low white cowpea. Pod's about that long, and it's sort of a bush type. It had runners, but they were short enough so you could call the whole thing a bush. It was still too late to finish before the rainy season started. And from my point of view, I really want my dry beans to finish off in August. So I'm not irrigating at that point. When you cut the irrigation off, it helps the plants dry down quickly and just ripen all the rest of their pods all at once. And you don't have the problem with moldy pods and stuff you've got when you're growing a longer season bean into the rainy season. So I considered the beginning of the rainy season is a cutoff. It's not very practical. It takes a lot more work to grow dry beans if you're going to have to grow them into the rainy season. So this this one, the earliest cowpea variety that I could find, this lady pea as it's called, these are also known as southern peas, was still a couple of weeks too late. I came and looked at the plants a couple of weeks into the rainy season and they were still green, except for one plant. One. You know, out of maybe 100 plants or so. Well, now if you're an optimistic, a cheerfully optimistic person, you immediately say, oh, that's probably a dynamite new mutation, and you know, to something that's earlier. If you're a 73-year-old, or even back at that point, maybe a 53-year-old old codger who's somewhat cynical, you say to yourself, 50-50, that thing's diseased. It died because the disease killed it off. And so the first thing that you do is look at the plant and you say, why are you early? You know, you want to see what its productivity is like compared to the later plants. So you know, I'm not talking about trying to measure anything, because you're just talking about comparing one plant to the rest. But the question is, you know, is this a disease? Well, diseases are viral diseases. Willamette Valley is famous for its aphid-transmitted viral legume virus diseases. So it would not be very surprising if it had a virus disease. Sometimes you can see signs of viral disease by distinctive patterns like mosaics or marks or wrinkled leaves or something like that. But even if the symptoms are completely invisible, there's one thing that's pretty distinctively true, and that is if the plant is seriously diseased, it doesn't yield well. So the first question was just, how's it doing in terms of yield? Well, it had almost the same amount of beans on it and almost the same weight of beans on it as the plants that were a couple of weeks later. You know, slightly less, you know, as you might expect with a bean that's a couple of weeks earlier. That 2 weeks made all the difference in terms of making this practical. So the next question, well, is this, you know, it could have been earlier because something nipped the root off, and so it died faster at that point. Is this genetic? So, you know, the first thing you do. Now, if you've got no curiosity, what you do is you simply dig under the whole planting, because one bean plant out of 100, you know, obviously this variety is not what you want. If you've got a little bit of curiosity, what you do is the opposite. You say, oh, well, I'll save the seed from that one and dig under all the rest. And this is called selection. Sometimes selection is very sophisticated. Sometimes selection is just, well, I saved the seed out of that one because it was the only one that produced seed. That sort of thing happens all the time. So my sophisticated genetic selection program was, there was only one plant that produced seed, so I saved it. Okay, so I planted it out the next year. Well, all of the plants finished off their seed in August. So I grew it a few years, just increasing the number of the amount of total seed available. And each year I discarded maybe ate the half the plants that were later and kept the half the plants that were earlier. each time inspecting and making sure that the yield of each of the plants that I was keeping was good. Easiest plant breeding project I ever did, it was pure breeding at that point. Obviously what had happened is there had been a recessive mutation, made the plant a little bit more determinate, and that made it a little bit less of a short vine plant and a little bit more of a bush. So then, of course, I needed to come up with some sort of jazzy names, so I called it Fast Lady instead of Lady. So it's Fast Lady Northern Southern Pea instead of Lady Southern Pea. That's sold by a number of seed companies now, including Fedco. It turns out to be, it was southern adapted to start with. It tolerates cold nights better than most. So it actually grows in New England, and it's sold by Southern Exposure because the people, they have dozens of cowpeas. It's their very earliest cowpea, and that means that it can be grown by Southeasterners in the Appalachian Mountains, where they have cold weather too. It was just a simple matter of just saving seed from one bean plant. All I was looking for is a variety that would develop seed here. Sometimes plant breeding is exactly that easy. So this bean has actually extended the range for production of, practical production of cowpeas. And it would be very nice if I could say, well, that's because I'm so smart and sophisticated as a plant breeder, but wasn't my idea at all. It's just one of those things that happens. That's one of the main things that a plant breeder needs to do, is to be opportunistic, appropriately opportunistic. You never know when you see an odd plant, in fact, whether that's actually genetic at all, because you could have gotten a little bit of spray from the neighbors, so it got some herbicides on it, and then, it is looking funny because of that. Plenty of times things will show up that they might have a genetic component to it, but it's pretty vague, and it's not doesn't show up consistently, and so it's not something you can depend on. The other bean project I want to tell you about, I really, really wish I could take full credit for this one. But again, it was another thing. It was pretty much just an accident. I was just trying to do a seed increase on black tepary, which is a bean that I had got from Alan Capular, one of the few tepary beans supposedly that grows here. And I was simultaneously doing a seed increase on one of my very favorite heirloom varieties. Actually, my very favorite heirloom variety is an Argentine heirloom called Gaucho. It's a yellow bean that yields very well, and it's very early, and has got a very rich, full flavor. So I had a little patch about 15 by 15 of black tepary beans, completely different species, and this Gaucho, this common bean. And the next year I took my yellow beans and planted those out, and I got about 5% plants that had black beans on them. And I said, whoops. Well, I'm not much of a plant taxonomist, so I took my supposed black tepary bean and gave it to a couple different people, and one of them being Jim Myers at OSU, to look at the flower anatomy and tell me whether this was really a tepary bean or not. And one of them said, well, it looks like a tepary bean to me. And Jim Myers said, well, you know, the flowers look sort of somewhere in between a tepary bean and a common bean. But he figured it was a common bean. That's a matter of interpretation. I think what happened was that there was a spontaneous cross between those two species at some point in the past, in the long distant past. And what I got as black tepary was mostly common bean at this point. Well, I continued to increase the seed. The second and third generation, I got seeds that was a mix of all of the colors that you might imagine from the cross that I speculated had happened. That is, I got yellow beans, and I should say the so-called black tepary and the gaucho were beans that were similar in size and shape. Black tepary was a black bean, and gaucho was a yellow bean. So by the time I was into the third and fourth generation, I had enough beans for starters to taste them and see what this mix of beans tasted like. And I had a very interesting mix of beans. They were all the same size, and both parents had been the same size. But most of them were black, about 3/4 of them were black. The other 1/4 was a mix of brown and yellow. When I tasted the beans, it was a really interesting experience. The beans tasted extremely beef-like. They tasted more like you know, braised, properly seasoned, you know, dry cured beef that's been browned. That's what they tasted like. And most black beans are a full flavored bean and have got a meaty flavor to them, but I've never actually tasted anything. This tastes more like a beef stew, so much like a beef stew that when you add beef to it, you actually dilute the beefy flavor. Well, you know, a bean that tastes that much like beef, well, that's sort of fun. And the beefy flavor was all associated with the beans that had that black color. Michael Mazurek at Cornell and one of his graduate students are actually, I mean, they've tried the bean too, and they agree that it tastes like beef, and of course that's interesting. And they are taking it into the laboratory to try to figure out how it manages to taste like, how and why it tastes like beef. So that's a nice project for a graduate student. But meanwhile, I've got this mix of beans. When I crossed the gaucho, gaucho was a very early bean that was a tight bush bean, so it was very easy to harvest in August. And the so-called black tepary, which is clearly not completely tepary, it's probably just a little bit tepary at best, it had short runners, about 2-foot runners, but the runners actually all stick in the air, so it's sort of like a, you know, grows like a bush. You can grow it like a bush, except that the runners tangle up with the neighbors, and so instead of trying to harvest individual bean plants, you sort of need to just cut all the plants and roll them up. But they had different maturities because the parent material had different maturities, and so it overlapped into the rainy season. So I started gently selecting for earliness, and I also started selecting for bush types. So I started off with this F4 and F5 material that I called, I think, beefy resilient Grex. Okay, and so I started reselecting for earliness, gently selecting, because I didn't really want it to be quite as early as gaucho, because I didn't want to have to try to harvest whatever bean this ended up being at the same time as the gauchos. You know, I really like them staggered a little bit. So it'd be fine for it to be a little later than gaucho, but not too much later than gaucho. So I gently selected for earliness, selected for bush because even these short vines are agronomically a nuisance. Because what it amounts to is it makes the plant indeterminate, even though the vines are short. That means it keeps producing beans. And so when you've got most of the beans dried down, you still have got a whole lot of greenery, biomass. You end up having to harvest the beans and, put them somewhere in the barn or something to let them finish drying down. I would really prefer to have all bushes. So that's the ideal material from which people can grow all, can select different kinds of beans for different areas. But agronomically, I'd much rather have bushes, so I selected further for that. So now I've got a selection out of that I call Beef Bush Black Resilient. I'm still working on improving that. And of course, there is a Beef Bush Brown Resilient. Well, one of the advantages to the Beef Bush Black and the Beef Bush Brown is that these are basically sister lines. They've got a genetically uniform background, basically, except for probably one gene difference between them. But that one gene difference completely changes the flavor, so that the browns have got a meaty flavor, but it's not beef-like at all. And the blacks have got a beef flavor, and the gaucho has got yet another flavor. So I can grow the blacks and the browns. You can put the browns in one end of one row and the blacks the other end of the row, and you can eat the section of the row where they come together. And an occasional cross between the two is no big deal since they're derived from the same material. They're sister lines, basically. Before you plant, you just, separate any occasional off color types out. And I call this sister lines. Really facilitates seed saving because it means that instead of having to restrict the number of bean varieties that you grow to how many isolation niches you've got, if you've got, say, 3 or 4 sister lines, material that's essentially genetically the same except for the color difference, but the color difference gives you all different flavors. That's really cool because now you've got several flavors of beans and you can grow them all in one patch. I do that with corn lines as well as bean lines. So this was another project where basically I was just minding my own business, just trying to do seed saving. And I wasn't expecting these crosses, but there they were. I thought I was dealing with 2 different species. Well, if they were different species, they weren't enough different species. And ended up with something really neat. The flavor of the black beans is just so magnificent. I really, really wish I could take credit for it and say, oh, I thought of this brilliant project that gave me a bean that tastes like beef. But I didn't. It just happened. The thing that I did was when something just happens, I always taste them. And I taste them every possible way. When I'm breeding winter squash, for example, I taste them as summer squash. When I'm breeding summer squash, I taste them as winter squash. Just, be open to the possibility that, even if this thing is not as useful as what you were growing originally, there may be other possibilities, things that it's really better for. So part of being a good plant breeder is being opportunistic, and part of it is being versatile enough to, instead of ask the question, why aren't you what I was trying to grow? You say, what might you be that I didn't think of growing? What might you be better at than anything that I was growing, or than anything that actually even exists? So let me see now. I want to talk about squash, some of my squash breeding projects at this point, and I want somebody to put on here on the whiteboard for me, and I'm just kind of tied down here.
We will be your team.
Yeah,
aides.
just give me a simple heterozygote that is, say, a large T and small t.
Okay, you're in front. Oh, boy. What color do you want?
Make it nice and big so that people in the back can see it. So we just need a large T and a small t to represent something bigger than that. Yeah.
Are we doing a square in the back? Do you want a Punnett square or just?
And just below that, put 1/4 large T plus 1/2 the heterozygote plus 1/4 small t. Now this is actually the only thing I needed the whiteboard for.
Do you want me to draw the Punnett square?
No. Okay, so the way most squash breeding is done is people will start off, say, doing a cross. And one of the major reasons, the situation that makes people do a cross is you've got a variety that's got some characteristics you really like, but it's missing some characteristics you would like. And you can find those other characteristics in some other variety. So what you do is you cross the two. And this basically brings the genomes into one place. And in my breed your own vegetable varieties, I go into ratios and technical details and so forth and so on, but I'm going to be very empirical in this talk, and say basically what amounts to when you do a cross, you're merging two gene pools, two genomes. Now, if the next step is that you go to the F2 and then you inbreed from there, the way most squash breeding is done, what happens is when you inbreed, you lose genetic heterogeneity. And so let's suppose we started off here with one variety that's large T, and another variety that's small t, so that the F1 is heterozygous. In other words, it's okay, give me the F1. Write the F1 down here. Really big.
Well, this is your. No, it's not. Okay. That's your F2.
So I want the F1.
F1.
So large T, small t. So this is what happens at one particular genetic locus that had a difference between the two parent varieties. So now it's got one large T because one of the parents had only large T's to donate, and it's got one small t because the other parent had only small t's to donate. So this has now got genetic heterogeneity in it for that particular locus, that particular gene. Now, when we inbreed, that is, we self-pollinate, what you get in the next generation is this 1/4 large T, 1/2 large T, small t, 1/4 small t, and you've all seen that, right? But here's another way to state it. I've lost half the genetic heterogeneity from one round of inbreeding, because now the half that's large T is still genetically heterogeneous, but 1/4 of the plants are large T, they become fixed for large T. They're no longer heterogeneous at that locus. 1/4 the plants are small t, they become fixed for small t. So just one round of inbreeding and we've lost half the genetic heterogeneity at this locus. The same thing is going on at every single other place that differed between the two parents. So if we had 20 genes that were different between the two parents, we've lost the heterogeneity. You know, if we just pull a random one out, we've lost the genetic heterogeneity for half of those genes. Well, plants like squash have got a tendency to be a lot more vigorous when they're genetically heterogeneous. A lot of times you can start off with a cross and, you know, it'll be very vigorous. And then you're selecting for stuff that grows very well under your conditions, and you inbreed it for a number of generations to get uniformity for the flavor and the size and the color and the whatever else you want. And by the time you're done, none of it is growing all that well anymore. So what do we do about that? Well, I think since we in the community who are breeding for organic adapted varieties on our own farms and gardens are not usually interested in putting intellectual property on our varieties. If you want to plant variety protection, for example, or a patent, you have to have very uniform material because the rules as to what you can put intellectual property on require it. That's deadly. Getting the thing that inbred, you give up a whole lot of vigor when you do that. It's almost impossible to not give up a whole lot of vigor when you do that. We don't need to do that. So one approach is when we do a cross, instead of immediately turning around and inbreeding, do as little inbreeding as possible. Now, I'm going to give a couple of examples from squash breeding projects of mine. One of them is a project I actually did on purpose. I really love Delicata, and the tan Delicatas, candy stick sugarloaf Delicata that was bred by Jim Baggett and Honey Boat, very popular in the Northwest. They've got a more intense flavor than the cream and green striped tan Delicata, or cream and green striped Delicatas. And I just love them. But the problem with Delicatas in general, including these tan Delicatas, is, for starters, they're dinky. And when I grow a squash, I mean for this to be the major carbohydrate. It's going to be the only carbohydrate in the meal. It's going to be a big part of the meal. A Delicata that is only 1.5 pounds and has got a flesh that's usually only about 1/2 inch thick, I'd have to prepare 2 or 3 of those and eat, 4 to 6 halves to get enough for one person. If I'm trying to feed company too, forget it. It's just too much work. Well, what to do about that? Well, one approach would be, gee, if the Delicatas were just bigger, if they were 2 or 3 times as big, Well, I've tried in the past various crosses of Delicatas to much bigger things, but basically, once you outcross to something that's not a Delicata, it's really difficult to ever get the Delicata flavor and texture back again. Another possibility might be just thicker flesh. But basically, none of the Delicatas have flesh that's all that thick. Well, so what about just crossing some of the Delicatas to each other, even though none of them have got fruits that are big particularly, and none of them have got flesh that's particularly thick. Now see, this is somewhat different from what you usually aim for. So just by comparison, when I wanted to develop a better flint corn, for example, I got a flint corn that had the colors and flavors that I wanted, but it didn't have good enough husk coverage, so it got very badly affected by worms. I crossed it to something else that had better husk coverage. So in future generations, I would be able to combine those two characteristics into one variety. So the best characteristics of each variety. But notice now I'm talking about crossing two varieties, neither of which have got the characteristics that I want. Now, why would that make any sense? Well, it does make sense, and it very frequently works. And the reason that it makes sense is because two different Delicata varieties might be the size that they are for different reasons. So imagine that one Delicata variety has got, say, these three genes are contributing to it being a larger size, and this other Delicata is the same size, but it's a different three genes that are contributing to that size. So if I cross the two, then I've got heterogeneity for 6 genes. That means that in subsequent generations, I've got the potential of pulling out something that's got 6 genes that contribute to size. That could be bigger than either parent. So while it's usually the case that when at all possible, you choose parents that complement each other, that improve each other, sometimes you don't have that option, and sometimes just crossing two things that you like both of them, but this sort of thing can work. Now it could work on any sort of characteristic. So I could cross two different Delicata varieties, and if I lucked out and they happened to be that size for different reasons, I could pull out a bigger one. Same thing could work for flesh thickness. They could happen to have that flesh thickness. They might have different genes contributing to flesh thickness. I might be able to pull something out with thicker flesh. Well, there were 4 possible Delicata style plants that I thought might make useful parents. One of them was sugarloaf. One of them was honey boat. Those were the 2 original 10 Delicatas that Jim Baggett developed. And one of them was Cornell bush, and I figured that was a more distantly related population because that actually had some transfer of characteristics from wild squash in there by breeders at Cornell. So that might make a especially nice cross. I mean, just as a guess, that would be more likely to contribute different genes to one of the 10 Delicatas than the 10 Delicatas that had originally been one plant at one point 10 generations earlier. So And there was another Delicata that I intended to try, but the seed was none of it came up. The seed was all dead, so that got eliminated. So basically I had 3 Delicata varieties, crossed them in all possible combinations. Instead of, in other words, making just the cross that I thought was the most likely to give me the results I wanted, I sort of said, well, theoretically speaking, from first principles and my vast genetic knowledge, this is the cross that would be most likely to do this. Now, how seriously am I going to take that vast genetic knowledge? Try it all. Ask the plants. It's a lot easier and more reliable to ask the plants. All I had to do was get F1s from all possibilities. Well, it turns out that the F1 that gave me the biggest fruits with the thickest flesh, and there was one particular combination that gave me substantially bigger fruits and thicker flesh in the F1. And that was actually the cross of Honeyboat and Sugarloaf. So it's exactly the cross that I thought was the least likely. And that F1, that gave me some plants that were, half again as big as either of the parent, and that had 1 inch or 1 inch and a quarter flesh thickness. Now, partly I thought that the flesh thickness, a lot of times flesh thickness has something to do with just the vigor of the plant. So that might be part of what was going on. Those F1s were just very good, just the way they were. But there was something else that happened too, and it happened right that very first generation. The flavor of that F1 between those 2 lines did not taste like either parent. It had some of the components of tan Delicata flavor, but it had a flavor I'd never tasted any time before in any squash ever. And it's the flavor of a medjool date. It really tastes like I took a Delicata squash and crossed it to a medjool date tree. Well, that was fun. My guess is that I picked up a recessive modifier in there that had changed the flavor. Not anything that I was expecting particularly, but boy, was that fun when it happened. So then in subsequent generations, without inbreeding at all, mind you, and I should go back one step, I didn't simply cross those 3 varieties in all possible combinations so that I got 3 different crosses. I tracked the individual female plants and individual male plants and evaluated the plants at the end of the season, because usually in squash varieties there's a fair amount of genetic heterogeneity, and that means some of the individual plants are much better than others. So I wanted not just a cross of, the best cross, the cross of Honeyboat and Sugarloaf. I wanted the best Honeyboat plant crossed with the best Sugarloaf plant. And I probably would not have been able to get that bigger size and that thicker flesh if I had just made random crosses between the 2 varieties. Well, so after that, I simply mass selected every year. I just kept the biggest fruits that had the thickest flesh and tasted the flavor of them raw, and selected for a few years, and after a while I released it as a candy stick Delicata. That's where that came from. That particular one was fairly widely adapted. So How are we doing on time here?
We got 10 minutes.
10 minutes left?
Yeah.
Okay.
Do you want to talk for another 5 minutes, or you want to take some questions?
Yeah, let me talk for another, well, we've got 10 minutes left. Okay, I'll talk for 5 minutes more just to go real fast here.
Okay.
One of the things that I want to talk about Goldini zucchini. This is a cross that I bred to be, or a squash I bred to be simultaneously a really good summer squash as well as a really good drying squash. Those of you who have read The Resilient Gardener, and I should mention all of my books have got a lot of plant breeding in them, but not just the first one. Those who bred The Resilient Gardener, I talk about drying squash. If you've got it, and go into figuring out what made a good drying squash, some squash, when they're sliced in as summer squash stage and dried, they give you a really distinct, delicious flavor. And if you breed specifically for that characteristic and play your cards right, you can end up with something that's delicious in the summer squash stage, but if it escapes and gets a little bit too big, you've got a wonderful drying squash, and you can dry that down and make a staple cross for the wintertime. What I did with that is the most vigorous organic adapted variety I know. It's fairly uniform for the squash characteristics. It's a yellow zucchini squash. I bred it to be prime at that size because that's better for a drying squash than littler. But I also bred it to be, as far as I know, the fastest growing, most vigorous squash on the planet. And I've looked at it side by side with hybrids, and it makes the hybrids look wimpy. It's earlier than the hybrids. All of my other squash, including the ones I bred myself, by the time that the plants have emerged and are starting to produce their first true leaves, these are whole plants that are 6 inches high. Ridiculous. Well, one of the things that comes down to is thinning appropriately. I got the idea for how to thin and make this an integral part of organic plant breeding. Again, by accident. I was messing around with a pea breeding project, and a quarter of the seedlings that came from a particular plant were yellow. In other words, they were a chlorophylless mutant. They were doomed to die. But the fact is, they came out of the ground and they were yellow and they were growing just as fast as all of their siblings. And they grew exactly as fast as all their siblings up until they were about 2 inches high. 2 inches, almost 3 inches high. Then they just stopped dead. That was really interesting because that told me that basically pea seed or bean seed or big seeds like that actually are getting by on the chloroplasts and the biochemistry that was laid down by the mother plant that produced the seed. So if you thin at an earlier stage than that, you're not actually selecting for the genes that are in that plant. So in my song about 4 inches high and it's time to thin, it might be 3 inches, but if you're talking about selecting for corn, beans, or squash, you want to lay down excess seed, but you want to space them widely enough so that you can let them get that big before you do any thinning, because only after that point are they expressing their own genes. Up until then, they're expressing the mother's genes. If you use that trick with your thinning and you always lay down excess seed, you can lay it down in wide rows and then end up with a single row. You can get very strong selection for extreme vigor and fast growth. It's a game changer in terms of being able to select for organics. And I will, I'll stop there because we'll have the rest of the time for questions. Questions?
So before we do questions, we are actually pretty tight on time, unfortunately. So I'm going to ask those of you who have been here this morning on bus A to gather yourselves and get on the bus so you're not late to go talk to Andrew and Sarah at Adaptive Seeds. And we're just going to kind of transition. We've got to get Carol's recording equipment off and back to Adaptive as well. So please join me in giving her a big round of applause.